Hello everyone. So in this video we will start with chapter 10. So chapter 10 is basically we will doing a lot of reactions with compounds that has a carbon atom. Obviously the carbon atom is sp3 hybridized carbon atom, and it's connected to an electronegative atoms. It could be anything. Let's call it the electronegative atom is Z. So this is and more electronegative atom that is connected to it, right? So we will be talking about the reactions of halogens, where it's connected to halogens like chlorine, bromine, iodines, or it could connect it to our alcohol, or it could be reaction of epoxide, it could be reaction of ether. So we have all sorts of reactions that we're going to be talking about in this chapters. So this is our class 2 compounds, right? So quick introductions from your organic 1 regarding the pKa of an acid. So let's say we have HX and HY. Quick recap. So let's say HX ionizes to H plus and X minus, and this also ionizes H plus and Y minus. So let's say pKa of the first reaction is 10, pKa of second reaction is 12. Question is, which is more acidic? That's our question 1. Which is more acidic? So pause your video and try to answer. If you cannot answer, revise, then come back to this sections. So what's the rule? Lower the pKa, stronger the acid is. So you can put that rule in there. So obviously stronger acidic would be HX. So the answer is lower the pKa value, stronger the acid. Okay, so next questions. So between X minus and Y minus, which one is a stronger base? So pause the video here and try to answer your questions. So right now we have found out that HX is stronger acid. Okay, so which one would be a stronger base? So the answer is, the stronger the conjugate acid, the weaker the conjugate base. So stronger the acid, weaker the conjugate base. So in this case, X minus would be weaker base, because the corresponding conjugate acid, which is HX, is going to be our stronger acid. So if stronger acid, the corresponding base would be weaker. So this concept kind of comes over and over and over again. So make sure you get this portions. Stronger the acid, weaker the base. So obviously weaker acid, the stronger base. So if the acid is weaker, so the equilibrium sign would be more biased towards our acid sections, right? All right, so our answer for this question would be, so which one would be our stronger base? Y minus. Then between X minus versus Y minus, which one is a better leaving group? So which one is a better leaving group? So the answer to this one, pause your video and try to come up with the answer. So answer to this one is, so let me explain here. Let me write here. So always remember, stronger always wins, right? So stronger always wins. So weaker the base, better the leaving group. So a strong base can replace a weak base. So which means the weaker base becomes a better leaving group. So which one is our weaker base, X minus or Y minus? X minus is our weaker base. So X minus would be our better leaving group. All right, so let's do one problem right now, then you will be getting more familiarized yourself with these concepts. Okay, so let's say I'm gonna draw a couple of reactions here. So let's say we have CH3OH and we try to react with Br minus. So let's try to figure out if Br minus can replace our OH minus. So let's say, can we do this? CH3 Br plus OH minus. So the question is, can we do this? The question is, can we do this? All right, so Br minus is coming in. So always start the arrow with the electron. And then OH is running away with electron. So in this particular example, so OH minus is our leaving group. So this is our leaving group. So this OH minus is our leaving group. And Br minus is acting as a nucleophile. So the question is, Br minus, can Br minus will be able to replace OH minus? So how can we figure this one out? So here is how we should do it. So we are comparing Br minus, which is here, and OH minus. So the stronger always wins and the weaker gets kicked out. So what is the conjugate acid of, so what is the conjugate acid? So Ca is conjugate acid. Maybe I should write this. So what is the conjugate acid of Br minus? It is HBr. What is the conjugate acid of OH minus? Water. So what is the pKa of HBr? This is highly negative, right? So I don't remember the exact number. It's probably -7 or something like that. The pKa of water is 15. So which one is most acidic? Or since we are comparing two, it should be more acidic. So obviously HBr is more acidic, right? So HBr is more acidic. So if it is more acidic, then the corresponding base would be a weaker base. H2O is a weak acid or weaker acid. So the corresponding conjugate base would be, let's color code this. So H2O is a weaker acid because its pKa value is 15. Lower the pKa, higher the acidity. And our OH minus, which is our corresponding conjugate base, is going to be a stronger base. So stronger the base, bad or worse the leaving group, right? So weaker the base, better leaving group. So in this case, OH minus is gonna be a bad leaving group. So you cannot replace our OH minus with a weaker base. Our Br minus is a weaker base. So Br minus is a weaker base and the leaving group is a stronger base. If it's a stronger base, then it is a bad leaving group. So based upon this, what should we conclude? That we cannot do this reaction. So can we do this? The answer is, can we do this? Answer is no, we cannot do this. What if we flip it? CH3Br plus OH minus. Can we do this reactions? So think yourself. So OH, based upon the same logic, OH minus is a stronger base. Stronger base means better nucleophile. And then Br minus, which is Br minus is a weaker base. Weaker base means better leaving group. So our reaction should be, it should be possible, right? So it should be possible. So we can be able to replace our bromine with hydroxide ion. So that's our substitution reactions right there. All right, so I think I'll stop the video here and we will move on to the next concept.